Hey guys, this looks like a fun one. We're given a giant rectangle made up of a bunch of other rectangles. These are the areas of these rectangles. We don't know the areas of the two yellow rectangles, but we do know they have the same area. And we want to try to find the area of either of the yellow rectangles. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, I want to cut this rectangle up into parts and give each of these distances these corresponding variables. And we're trying to find the area of this yellow rectangle, so let's put down question mark equals base of B times the height of Z. This is what we're trying to solve. Let's put a box around it. And then in order to solve this, we need to find something for B and something for Z. So let's see if we can do this. First, to do the B, let's focus on this blue rectangle. It'll be the base of B times the height of Y equals 40. And then to get the B by itself, we can divide both sides by Y. And that'll give us B is equal to 40 over Y. Does that make sense, Y? So now in the place of this B, let's plug in 40 over Y. Next, we got to try to figure out something for the Z. Well, both of these use a Z. Let's set the two yellow rectangles equal to each other. For this yellow rectangle, we have B times Z, and that'll be equal to this yellow rectangle, which is C times Y plus Z. And now from here, in the place of this B, let's plug in 40 over Y. And now we have two Y's and two Z's, so let's just get the C by itself. Let's bring the Z up top and let's rearrange everything like this, so we can easily divide by Y plus Z. And now on the right hand side, this Y plus Z divided by Y plus Z, this will all cancel each other out. And now we're left with C is equal to 40Z over Y times the quantity Y plus Z. This looks important. Let's put a box around it. Now we got to figure out what else has a C. Well, the only one we haven't used yet is this red rectangle. So we can say the height of X times the base of B plus C is equal to the area of 44. And now from here, we have something we can plug in for both the B and the C. So in the place of the B, let's plug in 40 over Y. And in the place of the C, we can plug in 40Z over Y times Y plus Z. So now we have X times all of this equals 44. Well, inside here, both of these terms contain a 40 on top and a Y on bottom. So we can factor out the 40 over Y, and we still have the X right here. And then on the inside, after we factor out a 40 over Y, this first term will become 1. And then we can add to that the second term, and after we factor out 40 over Y, we're left with Z over Y plus Z. And that'll still be equal to 44. I'm not sure what's best to clean this up, but I'm feeling like multiplying both sides by Y over 40. That'll get rid of all of this stuff, so we just have X on this side. And then on this side, we can rearrange it like this, and the 44 over 40 can simplify to 11 over 10. So the right-hand side is 11/10 Y. Now from here, let's give both of these a common denominator, so we can change the 1 into a Y plus Z over Y plus Z. So now these two fractions have a common denominator, so we can combine them into a single fraction. We have Y plus Z over Y plus Z. And that'll simplify into Y plus 2Z over Y plus Z. And now from here, to get rid of these denominators, let's multiply both sides by 10 and Y plus Z. So now on the left-hand side, the Y plus Z on top and the Y plus Z on bottom will cancel each other out. And that'll leave us with 10x times the quantity Y plus 2Z. And then on the right-hand side, the 10 on top and the 10 on bottom will cancel each other out, leaving us with 11 times Y times the quantity Y plus Z. I'm not sure what else to do here, but it's definitely important, so let's put it in a box. And now I think we're done with all this stuff. And now from here, we haven't done anything with the green rectangle or the purple rectangle, so let's write down both of those formulas. For the green rectangle, it would be a base of A times the height of X plus Y equals the area of 54. And then for the purple rectangle, it'll be a base of A times the height of Z equals the area of 18. And then from here, we can do elimination. We can do this row divided by this row. So you might be wondering why we could just do this row divided by this row. Ultimately, what we're doing, we're taking this equation and we're dividing this side of it by AZ, and we're dividing this side of it by 18. But as we already showed, AZ is equal to 18, so we're basically dividing both sides of the equation by the same thing. On the left-hand side, when we do this divided by this, the A's are going to cancel each other out. So we're just left with X plus Y over Z. And then on the right-hand side, 54 divided by 18 is equal to 3. And now to simplify this, I don't really like fractions, so let's multiply both sides by Z. On the left-hand side, the Z's will cancel, leaving us with X plus Y. And on the right-hand side, we'll have 3Z. Now from here, I'm not exactly sure what to do, but I do notice we have an x up here that's alone. So let's get this x alone so we can substitute inside here. We can subtract y from both sides, and that'll leave us with x is equal to 3z minus y. And we can substitute that in right here. Let's get rid of all this and get rid of the box. Let's copy this down and give ourselves some room. In the place of this x, let's plug in 3z minus y. And now we're done with this. And now from here, let's take the left-hand side and multiply all this out. It'll give us 60z squared plus 10zy minus 10y squared. And then on the right-hand side, this will distribute to each of these, giving us 11y squared plus 11yz. And now let's set everything equal to 0. Let's subtract 11y squared and 11yz from both sides of the equation. On the left-hand side, we can bring this down. The positive 10zy minus 11yz is negative zy. Do you zy? And negative 10y squared minus 11y squared is negative 21y squared. And then on the right-hand side, this is all going to cancel, leaving us with 0. And now we can smush this together and get rid of all this. And let's bring this up here. This is factorable. It ends up being the quantity 12z plus 7y times the quantity 5z minus 3y. And it'll still be equal to 0. If we were to multiply all this out, it brings us back up here. Anytime you have something times something equals 0, this will be true if either of those somethings is equal to 0. So first let's look at the 12z plus 7y equals 0. This is not possible. Z and y are both positive values. They cannot be 0. So there's no way 12z plus 7y can equal 0. So this is not a valid solution. And now let's focus on the 5z minus 3y equals 0. Our goal is to get the z all by itself. So let's add 3y to both sides. That gives us 5z is equal to 3y. And then from here, we can divide both sides by 5. On the left-hand side, 5 over 5 is z. And on the right-hand side, 3y over 5 is 3/5 y. Now we know that z is equal to 3/5 y. Let's go to this box and update the z to be 3/5 y. And now hopefully we're almost done. Let's get rid of all this and bring these up here. Let's break it out of the box and copy it down here with space for b and z. In the place of the b, let's plug in 40 over y. And in the place of the z, let's plug in 3/5 y. This y on bottom and this y on top will cancel each other out. And 40 times 3/5 is equal to 24. And that is the answer to our question. Let's give it a label of square units and put a box around it. In our given diagram, the area of either of these yellow rectangles is 24 square units. This one was pretty crazy. If I missed anything and there was an easier way to do this, please let me know in the comments. How exciting.